Hello and welcome back. My name is Vikrant Adhavle. I am partner of OOB Consulting and we have designed this software estimation for machine components in the name of VRiddhi. In last video we have seen how we are working with the rectangular boss and rectangular pockets. In this video we are going to cover, last video we have only seen that rectangular boss and round boss. In this video we are going to cover its pockets. So let's go over here. So let us take the very first thing is rectangular pocket. In pocketing we have only two strategies, that is counter and second one is spiral. The reason behind that is conventional milling in pocketing is very difficult to maintain because you have a corner radius. And if you have within corner radius and you would like to continue with use of conventional milling, then my recommendation is you go towards slot milling. Right, so let's go back to rectangular pocket. Again, in all these operations, you have the option of selecting single tool and second tool. We'll come this to a later point of this video. Let us start with single tool first. So we will select a strategy, counter machining 200.02.0.15, depth of cut 1 mm, tool diameter 25, number of tooth let us put it 4. Tool overlap, I think now you are very clear the parameters what affect your total cycle time is tool diameter and tool overlap. 100%. Let us start with pocket length. Pocket is 100. We have its pocket width of say 50, pocket depth of say 5 mm, and corner radius. If you mess up with the corner radius, you will have it in difficulty in getting the cycle time. You have taken into consideration like the corner radius will not breach the maximum limits, but it might, if not put proper, it might affect you. For simple example, if I put the corner radius of 25 over here and try to calculate it, it will calculate. Whereas for 50 width, 25 is as good as a slot. But if I increase it to 30 and try to calculate it, it will show me corner radius is having is a problem. Got it? So be very clear in what you are putting in over here. So I'll put it at 16 mm at the moment. It is just a rough value. We are just checking how we are going to work along with this. And click on calculate operations. You get the total cut length and non-cut length. As I said, the diameter and overlap plays a very important role. If I bring this overlap to 25%, my cut length increases, and so will my total time. For simple example, if I take, we know like the pocket length is 100, so the maximum diameter of a tool what we can insert in is 100. Let me put this 101 and try to calculate it. It show me. So we have taken a lot of care to ensure like some of the data which will not exceed the maximum limits, but then putting the right input is also in your hands. Okay, now let us have a look at rough and finishing with two tools. Since it's a pocket, you have the option of keeping the allowances on X, Y and Z axis. It means I could have finishing allowance either on the periphery of the pocket or on the Z of the pocket or equally on every aspects of this. Do keep in mind whatever value you put it in X or whatever value you put it in Y, the calculation of length will happen. Means the finishing allowance will be divided 50-50. That is 50% will go to the x-axis and 50% will go to the y-axis on the both the sides. I mean, I hope you are getting this. Let me explain you further. Suppose if you are kept in a finishing allowance of 1 mm, then 0.5 on say this is the x-axis, and you have kept it an allowance of 1 mm, then 0.5 will be here and 0.5 will be here. Same way, if you have kept an allowance of 2 mm on this side, then 1 mm will be here and 1 mm will be over here at the bottom. Because the tool strategy are working in the same manner. So let us add 1 mm, and even in the Z. After this, we'll remove the Z and see the effect on the cycle time. So again 200, let us use 0.15, 0.5 tool diameter. This time we are going to use this 26 tools and overlap of 50. Let us calculate operation. This is the timings what we are going to get. Now if I remove this Z, then practically you are just going to run this on the periphery of the pocket. You can also use your limit RPM over here and come down to whatever levels you want. Suppose if I limit this RPM, we have is 2548 and 3185. Let us limit it at 2000. Sorry. This is what the impact it happens. So this is very essential to key in the right kind of tooling parameters and all the different directions. One of the things, safe distance in X, Y and Z in pocketing, the only Z axis will play an important part, because safe distance in X and Y will be only air movement. It will not be taken into consideration for cutting movements. So since we have completed this rectangular pocketing, we will go to round pocket. Again, round pocket, same parameters, but you have to key in. Let us start with countering. 200.15, depth of cut is 1 mm, tool diameter 25, tool 4, 100% overlap. Will not limit the RPM. Final pocket diameter is 150. Final pocket depth is 5 mm. Pre-pocket, over here you have the option of, if there is a pre-hole already been done, then you could consider this. This is specifically been put over here because most of the time it might happen if it is a very large pocket, you could do the first operation by drilling and then continue with pocketing. So that is the reason why this pre-pocket diameter has been considered. So we will just at the moment calculate on this itself. So you have the total time of 4.3 minutes. And if I take it, then 50 mm is the diameter of maximum drill, what I could do it over here and calculate operations. Okay, pre-pocket depth is missing. 4 mm, let's calculate. You could finish this in 2.46 minutes. So this is how you are going to work around with all the parameters. We are trying to include many more functions, whether we could take it in profile milling instead of considering end milling, but it will take some time because what looks so easy might not be that easy for every one of us. Now let us look if we go with the spiral tool strategy. 2.45, not much of a difference. But if we consider this 0, 0, 4.29, not much of a difference in moving from counter to spiral. So that's all in this video. I think we have covered everything. It's the final, this thing is the slot milling. As mentioned earlier, the whole operations will be covered in a separate video because drilling itself is a huge chapter to cover. So again, over here, the same kind of parameters you have to key in. In slotting, it will be working on unidirectional mode. So every time the slot will happen, it will come back. So that's all in this video. I hope you are liking this and you feel the software will be of great value to you. So we are eager to hear back your comments because so far it has been used by only close friends of mine, and they are really happy with the outcome of this software. So if there are any suggestions, recommendations, or you would like to give any of the suggestions, please feel free to contact us. So that's all for the moment in this video. Thanks Etan for watching this video. Have a great day ahead.